Welcome, my friends. Let's say we want to graph the equation y equals 3x minus 7. Notice this line is in slope-intercept form, y equals mx plus b, which tells us that the slope, m, is 3, and the y-intercept, b, is negative 7. The y-intercept tells us that the point 0, negative 7 is on the line, so we can begin by plotting that point. Then we can use the idea that slope is rise over run to finish our graph. 3 is the same as 3 over 1, so we must rise 3 units up and then run 1 unit to the right to find an additional point on our line, which ends up being 1, negative 4. Now we can draw a line through the 2 points to complete our graph. Let's try graphing another equation. Y equals negative 1/3 x plus 2. In this case, the y-intercept is 2. This means the point 0, 2 is on the line, so we can start by plotting that point. Our slope is negative 1/3. This means we must rise negative 1 units, or fall by 1 unit, and then run, or move to the right, 3 units to be back to the line. This brings us to a new point of 3, 1. We can draw a line through the 2 points to complete our graph. Let's try graphing the equation negative 6x minus 2y is equal to 4, which is in standard form, ax plus by is equal to c. There are 2 main ways you can go about graphing a line in this form. One way is to first convert the line into slope-intercept form and then graph using the y-intercept and slope. To do this, we must isolate y by first adding 6x to both sides of the equation. This leaves us with negative 2y is equal to 6x plus 4. Dividing everything by negative 2, we are left with y is equal to negative 3x minus 2. From here, we know that the slope, m, is negative 3, and the y-intercept, b, is negative 2. The y-intercept is always the point where the line intersects the y-axis, which is always at the point 0, b, which is 0, negative 2 in our example. We can plot 0, negative 2 onto our graph. We can think of the slope of negative 3 as negative 3 over 1, and use the idea that slope is equal to rise over run to graph the line. Starting at 0, negative 2, we can rise negative 3 units, which means decrease by 3 units, and then run by 1 unit, meaning move 1 unit to the right, to find a second point on the line, which is 1, negative 5. Now we can draw the line through the 2 points to complete our problem. An alternative way to graph a line in standard form is to find the x and y intercepts. Consider the equation 3x plus 8y is equal to 12. Recall the x-intercept is where the graph crosses the x-axis, meaning y must be equal to 0. Plugging in 0 for y, we have 3x is equal to 12. Dividing by 3 on both sides, we get x is equal to 4. That means that the point 4, 0 is on our line. We can plot the point 4, 0 onto the graph. Recall that the y-intercept is where the graph crosses the y-axis, meaning x must be equal to 0. Plugging in 0 for x, we have 8y is equal to 12. Dividing by 8 on both sides, we have y is equal to 12 over 8, which simplifies to 3/2. This means that the point 0, 3/2 is on the line. 3/2 is the same as 1.5, so we can plot the point 0, 3/2 onto the graph. Now we can draw a line through our 2 points to complete our problem. Sometimes you might be asked to graph given only the x and y intercepts. Say we are asked to graph the line whose x-intercept is 1 and whose y-intercept is negative 3. The point associated with the x-intercept is 1, 0, and the point associated with the y-intercept is 0, negative 3. We can plot each of these 2 points onto our graph. To finish the graph, all we need to do is draw a line that goes through the 2 points, and then we are finished. let's try one final problem. Say you were told that the slope of a line is -1/2, and that the line passes through the point -5, 3. This is similar to the case when we graphed based on the y-intercept and slope. We should start at the point -5, 3, and then use the slope to find another point. The slope tells us to go 1 unit down and 2 units to the right to find an additional point. This brings us to the point -3, 2. Now we can draw a line through the 2 points to complete our problem. Alright, my friends, that completes our discussion of graphing linear equations.